Welcome back. Good evening, everyone. WDWT is going to be talking now with meteorologist Joe D'Aleo about extreme weather and its role in climate or connection to climate, if there are any at all. He's going to be exploring those things. He's joining us via Skype. Hi, Joe. Welcome.
Hi, Anthony. Thank you. Thank you for this chance to talk about one of my favorite topics, which is extreme weather, which enables us to have a business. On the Why are we talking about extremes? Well, the mainstream media certainly has, if you look at the first slide, has focused on extremes. They certainly started at talking about global warming, but that didn't seem to catch anybody's attention. So that morphed to climate change, and especially as temperatures leveled off. And then it became climate disruption, which then focused not on man-made warming, but on extreme weather. And that seems to have resonated with some of the public. So that's where the focus of the mainstream media and the alarmists has been in the last few years, especially. As Paul Watson, co-founder of Greenpeace, says, it really doesn't matter what's true. It only matters what people believe is true. And very relevant also is what Dr. John Houghton, the first chairman of the IPCC, said, unless we announce disasters, no one will listen. And so they're in the business of announcing disasters. If you look at the next slide, we can see that the problem is that temperatures have leveled off. 16 years now, we've seen no rise in temperatures. So they can't talk about global warming. The next slide, you can see that as that has taken place, that leveling off of temperatures, the CO2 continues to rise. It rose 9% during that same 16-year period. Now, before we go to the next slide, I just mentioned that Chris Folland of the Hadley Center talked about their projections and the fact that it wasn't, warming, or data wasn't consistent with what their projections were. He said, we're not basing our recommendations or thinking on data. We're basing them on the climate model. If you go to that slide there, you have there on a moment ago. Go back one. Sorry. That is along the top row is what the climate models suggest. The warming where it would be concentrated, not only in the high latitudes and low levels, but in the tropics, up around 30, 35,000 feet. There's supposed to be a warm spot, a hot spot. That's due to the warming oceans that produces convection, which releases latent heat in that region. But in the radiosonde, the weather balloons, we don't see that warming. This is the Hadley weather balloons in that period from 79 to 2012. You see it's actually down slightly, not statistically significant, but no warming. And likewise, the satellites show the same thing. And the next slide shows that ocean temperatures, likewise, in the tropics, where the heat is supposed to be building up, has been flat. This is the upper 300 meters of the ocean, most of the tropical Pacific from Indonesia to South America, and we see no warming to speak of in that period from 1979. The next slide, Kevin Trenberth, our friend from the IPCC, a lead author, said in one of the Climate Gate emails that climatologists are nowhere near knowing where the energy goes or what the effect of clouds are. We are nowhere near balancing the energy budget. And he could not account for the lack of recent warming and said it was a travesty that he couldn't. He suggested perhaps it was hiding in the deep oceans beneath the levels that we were measuring, but we just had a paper come out by Fu and others that showed in the Atlantic, the deep Atlantic, it's been cooling since the 1950s. So they're going to have to continue to play Where's Waldo with that heat and try to find it somewhere else. He also said none of the models are initialized to the observed state, and correspond to the current observed climate. So he wasn't very optimistic about um, the model performance in his weblog. On the next slide, you can see why. You can see the temperatures, in actual temperatures at the bottom in the circles, the satellite in blue and red, and the land temperatures in green and orange are well below the IPCC projected path for temperatures. On the next slide, another way of looking at that, the IPCC trajectory and the actual temperatures are diverging, even as CO2 continues to march upward. On the next slide, we summarized a few of the other failures of these models. The snow has been building over Mount Kilimanjaro, according to analysis study, and the Himalayan ice and nearby peaks have lost no ice in the last 10 years. The study shows that was portrayed in the Guardian. And then Al Gore's favorite symbol, the polar bears, instead of diminishing, they're far from decreasing. They're much higher than they were 30 years ago, according to the expert Dr. Mitch Taylor. Sea level, the next slide, has slowed down in its rise, and they've had to try to get it to appear like it's increasing, add an adjustment to the data that try to say that the land is rising after the last ice age and offsetting some of the what would be observed as a sea level rise due to glacial melting. But even with that, you can see it's not significant. If on the next slide, you can see the one of the major reasons for sea level rise, according to the IPCC and or alarmists like Hansen and Gore, is the melting of the Greenland ice core. But you can see Greenland temperatures have been going up and down every 1,000 years, but every peak has been lower than the peak before. The current warm period is less than the medieval, which is less than the Roman, less than the Minoan warming. So there's no dramatic warming taking place that's going to impact sea level. Go to the next slide. You can see actually the University of Colorado sea level trends unadjusted show that a change of 7 inches by 2100 is likely outcome of sea level rise. That's at the low end of the range from the last IPCC AR4 and well below the 20 feet that Al Gore and 240 feet that James Hansen have projected. Now, if you recall from Al Gore's movie, and on the next slide, you can see he used a crane. Remember that movie where he ascended in a crane to 20 feet to show people how high 20 feet was in the sea level? Well, if the UCO analysis is correct, he could have grabbed a couple of those phone books, the New York City phone books, and stood on that and saved himself some expense and got it come a lot closer to the truth than he did in his movie. If you go to the next slide, we hear a lot about record highs being set. And this was a chart that was shown in front of Congress by John Christie in August after the record July heat. And you can see that we didn't set any state records, and even as hot as it was in 1930, still dominates the record. These are the 50 state record high, all-time record highs. On the next slide, we looked at all 12 months for the 50 states. There's 600 records, and the same story. The 1930s stands out. The 60s and 80s were cold, and the 2000s were unusually benign. So in terms of temperature records, there's nothing unusual going on. The next slide shows the winter. Anthony, you used this slide on your site.
I did. I took a cue from your original version of it and made this one.
Yes, I did the original map looking at the 9 regions. All of them showed cooling over the decade, and you showed how each region had a downtrend in the 10-year period. We had a warm winter last year. If you go to the next slide, you can see even with that warm winter, the 15-year trend has been down 2 degrees per decade. And I did the same thing with the 15-year trend that you did with the 10 on the next slide. And you can see in every region, the trend is down, even with the warm winter last year. If we have a colder winter this year, that will continue and increase again. So what's the real reason for the recent flurry of extremes? On the next slide, we talk about um, a couple of possibilities. One is the strong modes of the Atlantic and Pacific natural oscillations. They're so strong, they tend to anchor the jet stream and allow persistence to reign. And when you're stuck underneath a ridge or a trough, you get to keep your weather, and it amplifies. You get a lot of rain, rains all the time, like it did this summer in the UK, or it's dry and hot, like it was in Russia and like it was in the central United States. That's one of the reasons. The other is we're in a mode with the cold Pacific where we see strong La Ninas and more La Ninas. And they often mean more tornadoes, cold winters, more snow, spring floods in the north, drought in the south, and then drought-enhanced summer heat. So a lot of what we've seen in the last few years in terms of extreme can be explained by the oceans and by La Ninas and by the Atlantic and Pacific. By the way, that warm AMO also means less Arctic ice, and with the cold PDO, more Atlantic hurricanes. And the next slide shows the Pacific Decadal Oscillation region. The Pacific Basin is very large, and when it's in its warm mode, much of the Earth is warm. The next, as that slide shows, most of the Earth, southeastern United States, a little bit cooler than normal on an annual basis in the warm PDO, but much of the ocean areas are warm. When you look at the Atlantic multi-decadal oscillation, the northern hemisphere is dramatically warmer than normal on an annual basis, less so in the southern hemisphere. So one would assume then, if the Atlantic is warm and the Pacific is warm in their warm modes, you're going to get a maximum amount of warmth in terms of global temperatures or U.S. temperatures. And if you go to the next slide, you can see that they're not exactly in sync. We're most likely, as we've said, the 40s to the 60s right now. But on the following slide, when you combine the Pacific and the Atlantic temperatures, and they both represent warm modes or warming factors and cold modes cooling, they track very nicely with the US HCN version 2 annual temperatures. When you smooth it, it's even stronger, as in that slide. On the following slide, that works in the Arctic too. You can see a very strong correlation with the temperatures in the oceans and the Arctic temperatures. And that's because in the following slide, you can see the Arctic ice is floating. If you go to the next slide of the Arctic region, you can see the warm, if you can advance to the next slide.
Right now we've got the PDO plus AMO and the Arctic annual mean temperatures up.
Let's go to the next one.
All right.
And you can see when the Atlantic is warm, warm water enters the Arctic underneath the ice through the Bering Sea and the Kara Sea. And when the Pacific is warm, it goes through the Bering Sea, Bering Straits. So warm water from both oceans enter the Arctic and diminish the ice in the warm modes. Now, in the next slide, this is from the International Arctic Research Center at the University of Alaska Fairbanks. They showed back in the 1930s in the top, the air temperatures in the Arctic were warm, comparable to current temperatures. And the sea surface temperatures in the bottom of the three graphs likewise were warm in the Atlantic. So the Atlantic warmth contributed to the Arctic warmth. And in the period in between, when the temperatures of the Atlantic were cold and the surface air temperatures in the Arctic were cold, not surprisingly, there was more ice. So these Atlantic temperatures relate to Arctic ice, the other big story they like to focus on. On the next slide, we can see a couple of examples of how this cycle exists in the Arctic. In Greenland, the 1930s were the worst decade according to Drinkwater in 2006, and the Kola Station in Norway, likewise, a similar kind of pattern. On the next slide, I think you've shown the Skate, USS Skate, the submarine, surfaced at the North Pole in 1959, in 58 and 59 in other Arctic locations, and both summer and winter, um, as at the end of the last period when the Atlantic was warm, when the Arctic was ice uh, ice diminished, as we see now. On the next slide, we can see how the Arctic ice diminished slowly during the warm PDO from 79 to 95, but after the Atlantic started warming in 95, it accelerated down. So that warm water from the Atlantic has accelerated the warmth. And as soon as that warm water begins to cool, and that will be in the next 5 to 10 years, the Arctic ice will recover just like it did in the 60s and 70s. If you look at the next slide, you can see the Antarctic, on the other hand, has increased and set a new record high at the same time the Arctic set a record low in 2007. The next slide shows area of the U.S. Exceedingly wet or dry, and there's really been no significant trend in precipitation, slightly upward in terms of rainfall, but there have been clustering of years, again related to ocean temperatures for the droughts and for wet decades, but that's due to ocean temperatures, not due to climate change. The following slide talks about hurricanes. That's Ryan Maui's ACE index, and it was at a 30-year low, even with more activity in the Atlantic in the last few years. Not a lot of landfall storms since 2003 in the Atlantic side, but and 2005 in the Gulf, but a very quiet Pacific because it is cold. And as you showed on your site, the number of strikes on land versus atmospheric CO2 certainly is not indicative of CO2 being the driver for increasing hurricanes, but very much the opposite. The slide that follows on tornadoes has shown a downtrend since the 70s, but we may see more spikes like we saw last year in 2008 and 10 because of the cold Pacific. La Niñas tend to favor more severe weather in the spring. And so I wouldn't be surprised if this started to rebound a little bit. This is one of those extremes that may increase. The others are showing very little trend or trend is down. The other factor besides the ocean that they like to throw out as being insignificant. If you go to the next slide, we all know that we have an 11-year solar cycle approximately, where the sun goes from being very quiet with few sunspots to being very active with a lot of sunspots. On the next slide, you can see that these 11-year cycles go all the way back, and they're not all the same. They vary. When they're very active, the sun is unusually hot. When they're quiet, the sun is cooler. And you can see at the beginning of each of the last 3 centuries, we had a cool sun with low solar activity, and we're seeing that again now. We're seeing that 212-year cycle. Let's go to the slide. We can see one of the reasons they want to downplay it is they focus too much on the brightness of the sun. It changes only 1/10 of 1% or 0.15 in the last cycle from the min to the max. Say that's not enough change in energy output to make a difference. But that is the visible portion. If you look at the indirect effects, ultraviolet component of sunlight changes 80 to 100 times more than the visible, and it produces tremendous amount of heat through ozone chemistry in the low and mid latitudes high up. And Schindel, who works for Hansen at NASA, has shown that. Geomagnetic storms warm high latitudes. We've seen the Svensmark effect. The active sun reduces low clouds by diffusing galactic cloud-forming cosmic rays. And Scafetta has posted on your site that total solar radiance is a value, but only as a proxy for the total solar effect, and suggests it may account for a very significant part of the changes, perhaps driving changes in the oceans. If you look at the next slide, you can see if I did a correlation of Hoyt, Chatton, Wilson's TSI with U.S. Temperatures, and like the oceans, it tends to follow very nicely. So I believe the sun drives the oceans, and the oceans drive the global temperatures, in this case, the U.S. temperatures. If you look at the next slide, our current solar cycle is indeed behaving like the beginning of 200 years ago, the early 1800s, 1798, cycle number 5, and when they started counting. And it had been projected by Clifford to be like that, and Svalbard and others to be much like the Dalton minimum. And as you look to the next slide, solar cycle 23 lasted 12.6 years, the longest in 200 years. Longer cycles tend to be colder, 800 sunspotless days, 3 times as many as recent cycles. Solar wind was the weakest in the satellite era. Geomagnetic field, which you focused on, was the weakest ever observed. It's still declining. Highest level of cosmic rays in the solar record, which means probably more clouds, low clouds, higher albedo. The next slide shows the cycles 21 to 24. You can see the current cycle is peaking at around a level of 60, about half of what the last cycle did in terms of sunspot numbers. And the last cycle was down 25% from the cycles, the 2 cycles before. So we are indeed heading down. If you only look at sunspots that were big enough to have been seen 100 years ago with the telescope, we're actually tracking very, very closely with cycle number 5, sunspot, the Lehman sunspot count. And just like the early 1800s, if you go to the next slide, that was the Dalton minimum, the days of Dickens and the children playing in the snow in London. And guess what? They have been the last few years. They've already been playing in the snow in England, and they'll do a lot more of that this winter. Now, the Russians think it's going to get worse than that. If you go to the next slide, they think we could go as far as the Maunder minimum, which Schindel at NASA suggested would look like this. When he considered his ozone factor, he focused on ozone and ultraviolet. And indeed, that is a brutal winter. And the little ice age in Europe is the next slide. Shows they had ice parties on the Thames River and on a regular basis. And we had a little bit of a taste of some harsh winters in recent years in the U.S. If you go to the next slide, you can see the Chicago in 2010 and 11 winter, and the next slide, my church up in New Hampshire. The kind of snow that we hadn't seen in quite a while. In fact, in the next slide, a lot of places in the East were praying for it to stop. So in New York City, on the next slide, you can see the top 2 months ever, 2010 and 11, February and January. And the third snowiest winter was 2010 and 11. So they were buried with snow the year before last. Last year was a dud, but it was a big year the year before. Back year before that, 2008, 2009 and 10 was a big winter. 2008, RFK Jr. had projected that children in the DC area would never be able to enjoy snow again because of global warming. If you go to the next slide, you see what happened very shortly thereafter. They set all-time record snowfall in the Mid-Atlantic, including Washington, Philadelphia, Atlantic City, Baltimore. And it was called Snowmageddon, as the next slide shows. As you can see on the next slide, the number of East Coast storms, even though both the NOAA reports and the IPCC said the snow for the big cities would be declining, has increased in the last 2 decades since 2000. And remember, we're only 3 years into the 2010s, and we've had 17 major East Coast storms since 2000. I have to go back to 1960 to find a comparable activity level. And we think there'll be more this winter. If you go to the next slide, the Union of Concerned Scientists and the IPCC said snow in the hemisphere would be diminishing. But we see after 1977, 78, 2009 and 10 ranked number 2, 2010 and 11 number 3, 2007 and 8 number 4, 2002 and 3 number 5. So 4 of the 5 top snowiest winters have occurred in the last decade in the hemisphere. So ironically, they talk about greenhouse gases diminishing snow. If you go to the next slide, the real irony was that record snow was damaging greenhouses in China recently, causing them to collapse. This was this year, this winter, early winter snows in China. On the next slide, just kind of summarize, if you put the ocean temperatures and the solar and the US temperatures together, they follow very nicely. Like I said, I think the sun drives the ocean drives the temperatures. Don Easterbrook, you may recall, as this slide has been shown next, the IPCC projection. And he believes if we just cool because of the oceans, similar to 1945 to 77, we'd see a slight decline. If the sun plays a role like 100 years ago or 200 years ago, like the Dalton, it'll be more significant, as shown by the bottom chart. Very different from the IPCC projection. Morner on the next slide has said that, well, if the sun plays a role, instead of the ice disappearing, as the IPCC says, and under A, we may see the ice in the Arctic really increase, as shown in 2040 there, because of the sun. So in summary, Gore, the IPCC, the National Academy, and other alarmist projections about dangerous ongoing greenhouse warming have been largely falsified by actual data. Scale changes in temperature trends and clustering of extreme events can be explained entirely by the combination of natural factors. And temperatures have stopped warming for 16 years and are about to decline, we believe, perhaps in an alarming way, if the sun plays a key role. And we'll look back at recent decades as the climate optimum, as extremely cold winters, shorter growing seasons, droughty summers, and we have to deal with poor public policy decisions driven by bad science, having put great stress on civilization as we know it and have enjoyed it for so many years.
I'd like to ask you, Joe, what do you think about why do people tend to focus on extreme weather as being connected to climate, where just a few years ago we'd get laughed at if we did the same thing? You know, if we pointed out a particularly cold winter and tried to connect it to climate in some way, we would be laughed at. But now it seems like they're embracing that very meme. Why do you think that is?
They ran out of other evidence to support their theory. The other parts of their theory have fallen apart. This is the one element that seems to have traction with the public. And they've tested this. The professional societies have worked with communications departments at Yale, at George Mason University, and said, hey, it's not working. The public isn't buying into global warming. What, how do we convince them? What works? And they tested like they do frequently in focus groups, and they found that extremes, you make a big deal of every extreme. Public said, yeah, that was a bad storm. Yeah, that was a cold winter. Yes, it was a hot summer. I don't remember summers like that. Boy, I don't remember a storm making landfall like Sandy. Um, but they're using anecdotes to try to save the theory. Whereas, as you said before, when we try to make a big deal of a cold winter or even a 10-year trend in temperature, we say, oh, you're cherry picking.
Well, I guess it's kind of, people tend to be able to experience weather. Experiencing climate is something you have to move to do. You have to go to a different place to experience a difference in climate. But you can experience weather. And so I guess the connection is well, if we can make people think they're experiencing climate when they're actually experiencing weather, well, then we can use that as a motivator. Would you agree with that?
Yes, yes. And the fact that because it's cyclical, and a lot of people weren't around last time we were in this same kind of, sun ocean mode that we are now. This is new to them, and that's why it resonates with them. And of course, in the schools, they've been told this since grammar school, high school, and now in college. They're, it's hard for them not to accept it. It's hard. It's going to be very difficult for us to try to bring reality to, unless nature continues to help us out, cool us off. Cooling Earth is far more of an issue than a general warming, as we've seen. As I said, we've lived in a climate optimum where we've been able to grow more things. Look at even this summer, this drought we had. Was comparable to the 1988 drought, but the crops were far better than 1988. Why was that? Well, maybe CO2. CO2 invigorates crops, makes them more drought resistant. It may have actually helped us get a better corn crop and a soybean crop, ironically, when they want to get rid of it.
Right. I wish I had that graph that showed the output of the number of bushels of corn per acre in the 30s when they had the drought then versus today. There was a huge difference, and a lot of that had to do with the improvements in our crop yields, the improved grains, the improved seed crops, and so forth. And without those things, we would have, of course, seen significant crop failures. But we've built up these drought-resistant strains of corn and wheat and so forth, and so we're better off. And a lot of people fear those sorts of things, but they've actually helped significantly.
Yes, and we're going to need to deal with shorter growing seasons too if it gets colder, and hopefully, shorter season crops, hybrids that don't need as long a period of time to mature. It will be probably the next thing.
Right. I was thinking back to 1974, in April of 1974. Both you and I experienced that tornado outbreak. Me, firsthand, I watched the Sailor Park tornado in Cincinnati. I watched it myself. And I'm sure you had some experiences watching and tracking that whole mega outbreak as well. And so today, we had a recent outbreak, like in Alabama in 2011. People are equating that to, being caused by global warming, but they would never have thought such a thing back in 1974. And as you point out, the big problem is that people aren't experiencing those things. They weren't alive then, so they can't look back on their experience and say, hey, this has happened before. So how do you counter that? What do you do for that?
Well, we try at WeatherBELL. Post frequently on it. Say this is we're reliving the 1950s in terms of hurricanes, or because the Pacific is cold, expect big tornado season, but not this year. We knew this year wasn't going to be because of the drought. But you can only try to educate. And predicting it in advance. Joe likes to say if you can predict something in advance, based on natural factors, then you're kind of showing that natural factors are the real drivers, not, you know, CO2 or methane.
Right, right. Okay, we've been talking with Joe D'Aleo, certified consulting meteorologist working with WeatherBELL Incorporated, one of the nation's leading private forecasters, which you can see online at weatherbell.com. Thanks for joining us. We'll be back with another segment soon.